Hello everyone, my name is Bashir Hamid and I'm joined by my teammates Daviani Vasta, Mordecai Chimedza, and Sumit Sharma. Our design project is the development of a bio-inspired autonomous underwater vehicle to be entered into the annual RoboSub AUV competition. What is RoboSub? RoboSub is a competition hosted by the RoboNation community. This is a non-profit organization with over 9 competitions and programs that engage students in STEM-related challenges. The RoboSub competition tasks mimic real-world applications like subsea exploration and navigation. The proposed AUV will be designed to attempt the challenge. Furthermore, a bio-inspired design will be pursued for improved maneuverability. My team and I also consider this a great opportunity to gain valuable knowledge and experience in AUV development. By considering the environment of operation and the requirements of the competition, some of the objectives of the AUV can be outlined. The maximum depth of operation expected is about 5 meters at the Transdeck Research Facility in San Diego, California, which is the venue of the competition. As a minimum to compete, the team would like the AUV to be capable of autonomous navigation, object detection, and location of underwater acoustic pingers, which serve the purpose of guiding the AUV during the competition. An advanced AUV may also attempt to drop markers, deploy projectiles, and move objects before resurfacing. These tasks are clearly described in the mission and rules documentation provided by the competition organizers. Some of the requirements of the AUV competition will be to enter a gate, distinguish between objects and images, as well as follow a specified path and resurface at a specified location. In addition to designing based on the competition tasks, it is also desirable to achieve a bio-inspired design, which will help improve maneuverability of the AUV according to evidence and research so far.
Hello everyone, my name is Sumit and I'll be going over the concept generation and concept selection methodology that was used in selecting the AUV design for the RoboSub competition. After sufficient background research and through help from our supervisor Dr. Tingzu, we came up with 6 designs. I'll briefly go over these designs. These 3 designs, Fish 1, Fish 2, and Fish 3 are bio-inspired and they were considered for their simple design and enhanced maneuverability. All of them have some form of individually controlled fins towards their back to mimic the control provided by fish's tail. The fourth design is inspired by Guitarfish and has a streamlined body just like it. It uses 2 individually controlled fins at the back to provide precise control and maneuverability. It has 2 thrusters in the horizontal plane and has 1 thruster in the vertical plane. There are also fixed fins in the horizontal plane towards the front to provide lateral stability. Next in line is the Loco Plus design. It uses 2 cylinders to form a frame and it also has 2 of those fins in the vertical plane towards its back end for precise control and maneuverability. Overall, it's a very simple design. The sixth and the final design that was considered was the Quaffle Plus design. This is inspired by an already existing AUV called Quaffle. It is a relatively compact design. It has 4 thrusters that have their power individually controlled to provide steer and maneuverability to the AUV. And also, as a novelty, these thrusters can rotate 180 degrees from vertical to horizontal plane. After coming up with 6 designs, the team came up with an evaluation criteria. All of the 6 designs were given a scoring between 1 to 10 with extra point for maneuverability, cost, and ease of manufacture due to their relatively significant importance. It can be seen that there was a tie between 2 of the designs, that's Guitarfish and the Quaffle Plus. Finally, after sufficient debate, discussion, and consultation from our supervisor, the team ended up picking the Guitarfish design due to its bio-inspired nature. which aids in better maneuverability and a streamlined body for better drag reduction.
Hello, my name is Davyani and I'm going to be going over our work plan. So our current work plan reflects our approach to achieving the design of the Robo AUV. At the moment, it's a Gantt chart which consists of deliverables of each of the subsystems of the AUV and a timeline to help us organize our actions. Currently, this provides us a general view of the project. Now, the plan moving forward is to get into even greater detail, and hence we are going to be using a project planning software like Microsoft Teams to create subtasks and immediate tasks and assign them to the different team members, and even attach progress reports or documents and track progress as we move forward. This in the long term will be very helpful to us as the team grows in number as we move closer to the competition. Next, I'll be going into some of our major milestones. An upcoming major milestone, as you can see, is the preliminary design. This includes the clear definition of each of the subsystems components and how they're going to interact with each other. A design that meets the basic requirements of the competition tasks and has some high-level design features. And the month after, the major milestone is subjecting this design to simulation and doing some virtual testing. And in the fall semester, we'll hopefully bring on some junior students on board who will help us with sponsorship acquisition and support us to achieve the other major milestones down the timeline.
Hey everyone, my name is Mordecai Chimedza and I'll be speaking on the budget for the project. Based on our current research on the equipment that would be required for the AUV, the total amount needed came to be about 7,000 Canadian dollars. This is greater than the $500 minimum that has been set aside for the project. In spite of this, however, we are optimistic of being able to acquire all the required materials. This is because we have learned from consultation that there are some potential sources of funding available. In addition, competitors from past similar competitions have indicated that it is possible to manufacture some of the equipment required, which is highlighted in the components table on the screen. In conclusion, we see this project as a unique opportunity for interdisciplinary collaboration. We also believe it is a great opportunity for Memorial University to showcase its competency on the international stage. Finally, we believe that the field of AUVs is a very relevant field for the university's context here in Newfoundland, and this is also indicated by the level of interest that a number of companies have actually shown in this field. And one example of this is actually Kraken Robotics, who have agreed to be mentors for this project. We envision this to be a positive learning experience for all involved and would like to thank you for your attention.